Good afternoon, everyone. Greetings from Vidyavartaka College of Engineering. I'm Madhushri, Assistant Professor from Department of Civil Engineering, doing Master of Ceremony for today's session. Welcome everyone for this GATE 2021 15 days training program, which is most important for you people for the last minute strategic preparation for your GATE examination. For today's session, we have two sessions we have planned. One session between 2 to 3:30. The second session is from 3:45 to 5:15. The first session is handled by Professor Chethan L. And the second session is on engineering mechanics, which is handled by Professor Kanmani Madam. For the first session, before going on to the introduction of the speakers, there are a few queries from the students and regarding the GATE examination, that is mock test, which was conducted yesterday after the inaugural function. I am very happy that we have received more than 1,200 plus students who have taken the mock test. I congratulate each and everyone and appreciate your participation in this training program. Still yet most of the students, we have received the queries that they have the examination. We can, frame one more, fix one more date, regarding the mock test, and we can give once more the test, the same test once again. And please show your interest in the chat box. If depending on the numbers, we would be happy to share our same test once again for you people, so that it will be again open for you. And most of the students have sent the queries that whether you can access all the session videos even after the completion of the training program. Yes, you can access all the videos of each and every sessions even after the completion of the training program in the YouTube, and all the daily basis flyers and regarding the details of the session, instructions, everything will be put up in the VVC website. Please go through our website, VVC official. All the details will be available there. So if any queries are there, please post all your queries in the chat box on the YouTube chat box. We'll make sure that we answer all your queries. And regarding the sessions, each session is 1.5 hours. I know that most of the students are very curious that how we complete all the sessions, all the concepts will be completed, will be covered within 1.5 hours. We will try our level best to reach all your expectations. The most agenda is that we reach the strategy of the GATE training program so that it is helpful for you to successfully complete your GATE examinations. So we'll move on to the session. I would like to introduce today's speaker, Professor Chethan L. Professor Chethan L is Assistant Professor in Department of Civil Engineering in VVC Mysore. He has got 3 years of experience. He has obtained his master's degree in Geotechnical Engineering from East West Institute of Technology, Bangalore. Knowledge. With this regard, I welcome Professor Chethan to the session, and I also wholeheartedly welcome all the audience for this session and get benefited. Over to you, Chethan, sir.
Thank you, ma'am. Thank you, Madhushri, ma'am. It was a nice introduction. So I will share the screen to start my presentation. Madam, is that the screen is visible?
Yes, sir. It's visible. Please go ahead.
Yes, ma'am. Thank you. Okay. I'm Chethan, working as an assistant professor in Department of Civil Engineering in Vidyavartaka College of Engineering. So first of all, today's session, I'm going to start the session with the soil mechanics as my topic. Here, first of all, I would like to, I would like to appreciate around 1,250 candidates have taken the exam successfully, and there are n number of queries regarding the exams, as well as in future also I expect them to take the post mock exam test after the recording, and I request everyone to use the utility that is we are providing. So here, first of all, let me start the session one. Today's session is the soil mechanics, and this is the first session. So here we go again. So here the basic concept that basically used to go for any of the winning strategy is, I personally believe that if we go with the Pareto principle, what Pareto principle says that is, for many outcomes, roughly around 80% of the consequences come from the 20% of the causes. Here you see 80% of the consequences, which basically means that 80% of the marks you can obtain from any of the examination can be obtained by the 20% of the causes. The 20% of the cause is basically the 20% of the syllabus. Here I am relating the consequences with related to the marks, as well as the causes I am relating to the syllabus, right? So as I mentioned about the syllabus, that is the 20% of the syllabus, whatever I'm talking about, it will give around 80% of the marks, which basically is given by the Pareto principle. The same way, if you look at, if you apply in the another perspective, that is the 20% of to cover or to get the 20% of the marks, we have to study about 80% of the syllabus. Example, somebody can ask me that how can you say this without any proof or data? Here I'm going to show you some of the data which I have referred by using some of the Made Easy textbook, which has been already available in the internet, as well as a soft copy. You can go through it. It's a wonderful textbooks which are provided by the Made Easy and ACA coaching centers. Here is the data that whatever the Pareto principle I told to prove that. Here I've taken from 1991, that is when the exam has been started, until I have analyzed until 2018. That is in 2018 also I've taken the 2 sets of paper. Here what I've done, the total amount of the marks which has been obtained from each year from the geotechnical engineering, I have put up all together and I've taken an average of it. Okay, so totally here I've taken almost around 28 years of the data, which says that the average marks can be obtained from a geotechnical engineering in every year, which is around 15.45 marks. Okay, so this is what I want to show. Why you have divided 2013 and 2014? Because here is that when the exam has been come to the online, it is basically come up with the 2 particular intentions, saying that there will be 2 sessions exam. So that also I have divided here. Okay, if you move on, as I'm talking about the previous year analysis, after I have done what all the, the major marks which has been distributed in every year, here I'm talking to you about what is the total number of questions which has been asked. Total number of questions. I'm talking about the number of questions. Here, the total number of questions which has been asked in the past 27 years, which is from the geotechnical engineering, it always stands with the first, saying 329 questions, which have been asked in the previously 27 years. And the next one, which tops, is the environmental engineering, which is around 235 marks. Sir, why you are giving all the analysis? Because I will get back to it, right? So here, and once again, as I'm talking about the past 27 years, in 2012, the GATE Board Academy has made a small announcement saying that the 100 marks of examinations will be conducted by giving including the 15 marks of the aptitude. So where is the aptitude part will come? So that will also I'm going to discuss later. Here you see, so here I have made a small analysis saying that the entire marks distributions I have already shown for the previous year, as well as for the particular subjects in civil engineering department. But here I have taken the entire data, which is including the aptitude test or aptitude questions. So the marks distribution for the average analysis will go like this. The aptitude will be 15 marks, geotechnical engineering is 14 marks, engineering maths is 12.5, environmental engineering says 10 marks, fluid mechanics 9.5, transportation is 8.5, solid mechanics is 7.5. Why I'm talking all these things? Because you see here, if you look at if you study only 4 subjects, including the aptitude along with the maths, that's it, geotechnical, environmental, fluid mechanics, and transportation. So you can able to get almost around 69.5 is the average marks we can able to get by only studying the 6 subjects. So say, no, sir, I want to study almost, not only 70 marks is not enough. If you want to go for more marks, you can study only by concentrating another 4 subjects. All right. Here, what I have done, I have just separated this, everything with respect to subject wise, and I have put the average marks. Right. So here again, the Pareto principle will come. If you want to get, example here, you see, if you want to get 70% of the marks, it is enough for you to study only about the 30% of the syllabus. Okay, that is what exactly I mean by that. Okay, that is why I have included the Pareto principle in the beginning, which says that 80% of the marks can be obtained from the 20% of the consequences. That is, here it is a syllabus, right? So further, let me move on. So now I'm going to start the particular soil mechanics analogy here. So welcome you all for the geotechnical engineering. As you all know that, right? So the GATE Geotechnical Engineering syllabus is basically composed of 2 parts. One is called the soil mechanics and another one is called the foundation engineering. The soil mechanics, in soil mechanics, basically it talks about all the basic elements or basic concept of the geotechnical engineering. But when it comes to the foundation engineering, you will be going to apply every concept, that is every basics we have been studied in the soil mechanics. So here is the brief description about the syllabus which appeared in the GATE. So now after that, I got some interesting topic here which says that you can see here, I have been working through Excel because I love to work with the Excel. So I go with some of the analysis with saying that what all the particular topic they have taken from a geotechnical engineering and how many number of time they have asked. So because you see here, it is not easy for us to study all these things. Again, I applied the Pareto principle, which says that, you know, the 70% and 30%, get a 70% of the result by using a 30% of the consequences, right? So here also I am doing the same thing again for a geotechnical engineering subject, and I went through the small analysis saying that these are all the main topics which have been asked in the particular all the 27 to 28 years of the question paper, saying that this is the number of questions they have asked with respect to particular topic. That is, in shallow foundation and bearing capacities always says at the top, because it has been asked that 50 questions have been asked from past 27 years. Okay, so then the second topmost, which always says as the properties of the soil, which is of 35 questions have been asked based on properties of the soil. The same way I have been listed all the topics along with how many number of times they have asked the question. Then later words, as I told the people that when they included the aptitude, that is the 15 marks in 2012, so I have not included the aptitude here, leaving the aptitude as said. I have taken the average for the particular total 85 marks. Out of that, these topics will say, example, these topics will say, for example, for shallow foundation and bearing capacity, it has been asked for 50 questions with total 2.63% amount. We can say that we can expect a marks from this particular shallow foundation and bearing capacity to an extent of 2.24 marks in every question paper. The same way I have been identified this particular topic and I have given the marks list here, saying that, as I mentioned in the earlier, the average marks which has given to the particular geotechnical engineering, which always says that around 14 to 15% of the marks, that is 14 to 15 marks, here we come up with 14.71 marks is the distributions we have taken from the last 27 years. So this is where the strategy comes. So next, as I told you people regarding the geotechnical engineering is basically in GATE, it has been divided into 2 individual topics. One is soil mechanics and another one is the foundation engineering, right? So here, whatever the previous slide I have put all the 12 topics, I again classified into which one is the soil mechanics part, that is the basic part, and which one is the advanced part, that is the foundation part. For that, again, I have divided these topics into 6 columns, that is property of a soil, classification of soil, clay minerals. These 3 are the theory part, that is very basic, right? So then again we have further taken up with the compaction soil, effective stress permeability, shear strength of the soil, same way, that is foundation engineering subjects. Here you can go with this, that is soil exploration, stress distribution, stability analysis, foundation, and retaining wall earth pressure, everything will come under foundation engineering part. So to cover the entire geotechnical engineering, we have divided the topics into 2 categories. One is called as the soil mechanics part, and another one is called as the foundation engineering part, out of which the soil mechanics, which has been allocated to me, I will be going to take the 2 sessions. After 2 sessions, today I plan to cover these 3 topics. The initial first 3 topics will be covered today, and the remaining 3 topics will be covered on December 1st. Okay, so let's move on, right? And I forgot to mention that the foundation engineering will be taken by our HOD, that is Dr. S.K. Prasad sir. He will handle the foundation engineering subject, as he is also one of the very best geotechnical expert, right? So now it's actually welcome to the family of geotechnical engineering, which says that here I will go with the introduction, where you see we are talking about the basics of the soil. As I mentioned earlier, might be a little bit theory, but it's only for the first 3 topics. Okay, so here soil is the most common, most useful, and the least expansive construction material. Every structure should be built on it. Example, see, one more strategy I am going to say you people before going to study this. My concept is very simple. I don't want you to study all the 100% of the syllabus. I never done. I basically go for, I always used to say that, right? If I study 20%, I will study the 20% exactly. Okay. Even I have taken the gate examination twice, and even twice also I failed. In first time, I got only around 1.56 of the marks, and second time I got around 13.56 by making the analogy, whatever I have done in the second attempt. So don't worry, always whatever you do with some clarity. So here I go again, that saying that, soil is the most common, most useful, and most least expansive material. Any structure you built above the soil or below the soil or by using the soil as a construction material. So it's important for us to know how the soil works, right? So whatever the questions which will appear from the geotechnical engineering, it will be easy when you understand the basic of the soil. Okay, why I am saying like this? Because soil is it is same as human being. It is also colorful, it is also sensitive. It is also sensitive. Why I'm saying sensitive? Because it will always express its feeling. Whenever the load has been heavy, it will express. Whenever any internal pressures, like any internal forces which attracts, definitely it will express its sensitivity. And also it possesses memory. How I'm saying it will possess memory? Example, if you take any solid block, today if it is able to resist 10 kilonewton load, if you are applied 20 kilonewton load tomorrow, it cannot able to resist it, because it is only capable of resisting 10 kilonewton. So it will possess memory. And also I'm talking about changes with the time. As human being has everything, it will also changes with the time. We know for different reasons or different seasons, right? So the soil will also change, and it will change to behave when it is in winter season or summer season, or it is basically changes how the water content will vary, right? So if I want to define the soil, basically you remember it is an uncemented mineral grains. Mineral grains or decayed organic matter with liquid and gas which is in empty pore spaces, which is formed by weathering of rocks in the top properties of the earth crust. So during the first part of my talk, I will be talking about the properties of the soil. That is the second highest marks which has been fetched in the previous gate examination. So because it is at the top, so I will go a little bit broader. Okay. So when you come to the soil is basically, as I mentioned, it is all about understand. If you want to understand the soil, you just think of a human being. That is it. Okay. So as we know that the formation of the soil has been formed, the formation of the soil has been formed by majorly two processes. One is called endogenic process, and another one is called exogenic process. What is endogenic? And one more strategy here I'm giving you people is that if you want to keep anything in mind or to remember very easily in geotechnical engineering, always understand the word endogenic. I will say throughout the presentation, I am going to talk about only by seeing the words. So endo means outside. So what is, endo means inside. What is exactly that particular meaning of the word? Okay. So here the endogenic forces, that is the inward forces, will be the main reason for the formation of the earth. So everybody know about the formation of the earth. So what is that endogenic force? It might be earthquake, it might be a volcano, right? When I'm talking about exogenic process, as here itself, the exo means outside, exogenic, the outside source is, or outside force is a reason for the formation of the soil, right? So how this process has been taken place? Basically, we know that the formation of the soil will take place in 4 different process in a cyclic manner, right? So either it might be weathering, mass movements, erosion, deposition, right? So what is weathering? Weathering is basically of, we know that physical weathering, chemical weathering, as well as biological weathering. Sometimes in the formation of the soil, they will ask a 1-mark question. So that's why I'm a little bit talking about it. So now, when I'm talking about the weathering of a soil, right? So weathering is, as I mentioned, it is basically due to physical, chemical, or it might be biological weathering. Physical weathering. The weathering is basically of, the obtaining the minute particle or obtaining of a complete cyclic process, right? Physical weathering. The physical parameters is the main reason for the weathering process. If it is a chemical reason, that is the the hydration process, the thermal process which takes place due to the chemical ion exchange. That is what the main reason. When I'm talking about the biological weathering, either it might be due to dead and decaying of the organism or fossil fuels, decompositions and formation of organics. That is the process in weathering. Here you can go through it. That is, the weathering breakdowning of the entire soil mass, then it is going to erode. And while eroding, there will be some agents is the main reason. Then it will somewhere it will deposit it, and some other agents will try to carry it, right? So to explain regarding that, right? So here I have put up a small slide which says that, anyway, we know that the formation of the soil has been taken place here. Let's assume the formation of the soil, it has taken it at its origin state, which basically called as a residual soils. If they are calling it as anywhere residual soil, means the residue is there at the origin, right? And another type of the soils which is called as transported soils. Now I am talking about the soils. Soils will be classified into 2 categories. One is called the residual soil, another one is called the transported soil. Residual means it will be there where exactly at the parent material is available. The transported soil is the one which has been transferred from the origin, right? So that's why it's called as a transported soil. Based on how it has been transported, it has been transported through some of the agencies. What are the natural agencies? The natural agencies, either it might be wind, or either it might be the rain, the sunlight, the glaciers, the ice, or anything, right? Based on that, the residual soils is basically a main reason for the formation of a gravel and sand, as well as when I come to the transportation soil, which basically classified in based on its agencies. Example, here I have put up a small slide, a small table on the left side, which says that the alluvial type of soil as well as transportation or deposition based on the agency which has been acted. The soils are again classified into transportation, classified based on transporting agents, right? So here I have put up some of the mix and match, right? So why I have done that? Because I think once or twice when analyzing that, I came to know that the questions which has been asked based on the type of soil, especially on the transporting agent, for 2 to 3 times, which composed of around 3 marks. So that's why I put up the slides here, which says that, the alluvial soil, lacustrine soil, collovial soil, aeolian soil, marine soil. This is the type of the soil. And here at the right side, I have put up some mix and match up. Right? So why I have done that? Because as I mentioned you people regarding, how we can easily remember, everything by knowing the words. Example here, you see, I will come from the bottom. That is marine soil. As the term marine indicating that, it is basically the agency will be sea, marine, sea, right? Next one is aeolian soil. We know that aeolian, which basically means that is the wind, right? You can transfer through the aeolian soil has been formed by the wind. Next one I will be talking about collovial soil. Collovial basically means that an attraction. What is the attraction? The attraction is basically from gravitation. So that is where I'm going to take it as matching with the gravitation. Next one, that is lacustrine soil. What do you mean by lacustrine? Lacustrine, basically LAC, lax, which basically means to the lake. So the soil which is called as the lacustrine soil is basically called as a lake. The lake is the major agency for the formation of lacustrine soil. Alluvial soil, alluvial is basically a river soil. So you can match up. Right? So sometimes basically they will give for match of the following, or sometimes the individual soil can be asked, type of the soil can be asked to identify which one is the agency. So it is very easy to remember based on the term. You can go for remembering that. Okay. Next one I will go. So next, now I am coming to the exact core part of my topic, which basically about talking about or understanding about the properties of the soil, how the soil mass has been seen. We saw the particular soil in through our naked eye, but when you observe it in microscopic view, the soil is basically composed of 3 major ingredients, which is called as air, water, and the solid particles. If you observe the particular soil mass in a microscope, the soil is basically composed of 3 important ingredients, which is called as water, air, and solid. Okay, now we understood that if I am talking about the composition of the soil, or if I am saying that soil, you have to remember these 3 things. That is, the entire composition will be composed of, one is a solid particle, which is basically the minerals which has been formed by the weathering, right? So, and the empty spaces which is available in between the particular grains has been filled with either air or either water, and sometimes both, right? So how it has been seen, that will be seen later. Fine. Now let me move on, right? So basically, as I mentioned about, there are 3 different phases of the soil, which is there. One is solid phase, liquid phase, gaseous phase, right? The solid phase, as I told you about, it is basically of the minerals or the solids, which called as a soil solids. The remaining 2, liquid and gaseous phase, which called as the volume of the voids, which basically calls as the voids. Voids means it's an empty space which is available in the earth material. Either you can expect the soil in all the 3 phases, or also you can go with the 2 phases based on its condition. So here you see I have put up both the matching of the microscopic view as well as the naked eye view. Here you see the soil mass. Whenever you see the soil mass, it should be appear like this. Okay, so that is the whatever the brown color is there, which indicates the solid part, and the remaining empty space has been filled with some which filled with water, and some of the spaces have been filled with the air, right? So let me move on. Am I talking about, whenever I say soil, you have to understand that the soil should be composed of 3 phases. One is the solid, and another one is the empty space. In an empty space, either it might be filled with air, or either it might be filled with water, or either it might be filled with both. Now I am talking about a solid phase. In a solid phase, as I told you, it will be basically of a minerals. Either it might be quartz, feldspar, or anything, or anything in case of a gravel and a sand. But when it comes to a clay minerals, it basically of a minerals of the clay will be present in it. And this always, next I'm talking about the solid phase as over. Now I will move on to liquid phase. It is basically composed of water. or sometimes the soil will also contain dissolved salts in organic soils. Remember it, remember it. So dissolved salts will be available in organic soil. Water, either it might be pure water or polluted water. The same way, the salts, either it might be soluble salts or insoluble salts. But when it comes to gaseous phase, it's basically atmospheric air. So this is where I have given a small descriptions that how it will be available in two phases and three phases. Here you see it has been two phase, that is dry soil. When it is completely dry, the entire void space will be filled with air. When it is completely wet, it is filled with water. When it is both are present, it will be filled with both solids, water as well as air, right? So now, when I'm talking about a phase diagram, the next important property, important parameters we have to understand in properties of a soil is phase diagram. What is a phase diagram? As the term itself indicating, it is a system where you are representing the different phases of the soil. We know that the soil, either it might be three phase or two phase, solid, liquid, gas, right? So same here, if you represent the phase diagram, why I am talking about a phase diagram? Because to understand the properties of the soil, we should know phase diagram. In representing the phase diagram, always the volume parameters will be represented on the left side, and the weight relationship will be represented on the right side. Example, here it indicates the weight of air, which is equal to 0. Weight of the solids, volume of voids, volume of air, volume of solids. It's in dry state. If it is a 2 state, if it is a completely saturated state, it will be filled with water, right? So the same way here, once you see this is the phase diagram you have to, we have been looking for, that is the entire soil composition will be composed into, while writing the phase diagram, the volume representation will be on the left side, the weight representation will be on the right side. In volume, example, this is the first one is air, volume of water, volume of solids, the total volume, weight of air, weight of voids, and weight of solids. The total volume, it's a combination of both the volume of solids as well as volume of voids. Here also weight of solids plus weight of water. There is no weight of air, right? So next I'm talking about what exactly, how to remember these properties. There are so many times even I felt struck. So to remember, how to remember this particular thing, right? So now as I'm telling you people regarding, whenever you want to understand about the soil, just think about the humans. Here also, void ratio, the terminology I'm talking about, it is a ratio between the voids. What is voids? We know that the voids is basically a volume of voids. In entire soil mass, VV indicates the volume of voids, that is the empty space. So here, void ratio, ratio of volume of voids with respect to its volume of solids is called as void ratio. Next, if I'm talking about porosity, what is porosity? Which is basically the porosity is, as the term itself indicating, here I will be going to write it. So void ratio, which basically called as volume of the voids which has been measured with respect to volume of the solid. Same way porosity. Now I am going to represent what is the amount of pores which are available in the soil mass. When the entire soil mass, if you take and this, the entire soil mass has been divided into three different categories, right? So one is the solids, one is the voids, another one is the water and air, right? Pores. How many amount of pores which is available in this entire mass can be taken as volume of voids by total volume. In the entire soil mass, how much volume of the voids are present? That is called porosity. Whenever there is a term which comes as saturation, next one is degree of saturation. Whenever there is a saturation, which basically always remember saturation is for remembering the water content, right? So why they are calling it a degree of saturation? Because the saturation can be 10%, it can be 50%, it can be 100%, or even the soil can be dry, right? So because all the soil cannot possess the same water content at all the time, it's natural. So degree of saturation, when it comes, the saturation is basically talking about the amount of water. How to define the degree of saturation, which is very basic. That is, we go with how much volume of water which is present in volume of voids. That is called degree of saturation. In a voids is the only place where the water can fill, right? So now you measure it with respect to how much amount of water which is available in the volume of voids. Next, what is air content? Here I am talking about saturation is all about water, air content is all about air, right? What is the volume of air which is available? Volume of watts, that is called air content. When you are talking about the percentage of air watts, which basically means that I am going to consider as a percentage, which means that the total volume of the air which is present in total volume will be indicate the percentage, the total in entire mass, right? So next one I will be talking about specific gravity. What exactly mean by specific gravity? Specific gravity is basically indicated by G. We know that specific gravity can be measured by taking the density of any substance. Either the substance may be soil or either it might be liquid or anything. It is always taken with respect to density of any material or any substance with respect to the density of a standard one, the density of a standard substance. Here we basically go for taking the density of a standard one as a water, right? So basically, while measuring the specific gravity by considering water as a reference, it will be measured at 4 degrees Celsius. Why it will be measured at 4 degrees Celsius? Because we know that the water has a ability to change when the temperature changes, but it will be at the maximum densest place when the water is at 4 degrees Celsius, right? So now I'm talking about specific gravity. Specific gravity is all about density of any substance with respect to density of a standard or reference material, right? So here I'm talking about specific gravity of a soil is basically the specific gravity of the soil solids with respect to the specific gravity of the water, right? So next one, unit weight. What exactly mean by unit weight? So unit weight is basically defined as, right? So weight by volume, right? What is the unit weight of the soil with respect to the volume of the soil, right? So unit weight can be taken in terms of different types of unit weights. Why it is a different types of units base? Because we know that the soil cannot be exist in only one state. Either the soil, it is basically represented by gamma. The soil, either it can be represented in natural water content, because we know that the soil will change according to the water which is present. So to remember the different kinds of unit weight, you can go like this. That is, if the natural soil which is available, if you are going to take the unit weight of the natural soil, which is called as bulk unit weight, it should be represented by gamma T. If the soil, whatever the soil you are going to consider in the soil, and if you are going to keep it in O1, and if it is completely dry soil, there is no water which is present in the void. So that particular unit weight is called as dry unit weight. And if you are going for saturated unit weight, what is saturated unit weight? Which has been completely saturated, which has been completely filled with the water. That is called saturated. But here sometimes you will expect the questions with saying that what is the submerged unit weight, or how to calculate the submerged unit weight. You can expect the question through the submerged unit weight. Submerged unit weight is always equal to gamma sat minus gamma W. In submerged unit weight, what will happen? The entire soil will be submerged, which will be immersed in water. Due to it has been immersed in water, what will happen? The water force will try to lift the soil particle up, which create some forces. That forces is particularly called as a buoyant force. This has been asked twice. So the buoyant force is only the reason where the submerged unit weight of the soil is always less compared to saturated unit weight. So we can easily determine the submerged unit weight by taking gamma sat minus unit weight of the water. Okay. So let's move on. This is the way we can remember. So if I'm going further, right? Okay. So index properties, what exactly mean by index properties are? Index properties is the property which basically used to identify the behavior of a soil. Now we understood that the soil is also acts like, and it behaves like a human. To identify it, we require some of the properties to understand. That properties is called as index properties. What are the index properties and how to determine it? We'll go detail. But here, as an GATE exam point of view, which basically one question will always fetch from these two particular points. That is, one is through particle size distribution and another one is through consistency limits, right? So I'm not going to discuss about water content specific gravity because we already discussed what is water content. Water content is basically a moisture, remembering what is the amount of water which is available in a particular solid mass. That's called water content. Now, as I told that in index properties, always you can expect the question from particle size distribution or through the consistency limits. So let's discuss one by one. To understand about the particle size distribution, the particle size distribution is a very important parameter while we have talking about the coarse grained soil. When I'm talking about the fine grained soil, the consistency limits plays an important role. If it is a particle size distribution where always the for gravel, sand, everything, the particle size, the size of the particles will plays an important role. But when it comes to the fine grained material, consistency, that is the plasticity, will plays an important role. Now, to understand the particle size grain distribution, the particle size distribution has been done basically by considering the individual size of the particle as well as the physical appearance, how this soil has been formed, what is the texture, what is the system or the structure of the soil. When I'm talking about the visible identification or a texture of a soil, the soil can be classified based on its particle size, as well as the soil can be classified according to its structure. Whenever if they ask the question based on structure, we already know that the soil structure has 4 different structure. One is single grained, honeycomb, flocculated, and dispersed. We know that always the predominant particle structure in basically the coarse grained soils are single grained and honeycomb. But when it comes to clay minerals, right? So when it comes to the formation of clay, always the flocculated and dispersed are the important key elements or key structures which basically available in clay minerals, right? So sometimes what they will do, they will ask about flocculated structure and dispersed structure, where what is the orientation? What is the orientation of the structure of the clay mineral flocculated structure? Basically, we know that the flocculated structure which has been formed through edge to face orientation. But when it comes to dispersed structure, it has been formed with face-to-face orientation. Remember, face-to-face is for dispersed structure, that is FDF. But when it comes to the flocculated structure has face-to-edge structure, that is FEF. Okay, remember that. Now, as I'm talking about the texture of the soil, as I mentioned about the different structure, next I will be talking about how we can classify the soil based on particle size and what all the questions can be asked, right? So basically, whenever we are talking about the particle size, it is basic influence on the particular gravel, sand, as well as cobalt boulders. That is coarse grained soil according to our IS classification system, right? So here, rather than I'm going here, I will explain everything in IS distribution curve. Basically, the particle size distribution has been done by using 2 methods. One is called sieve analysis and another one is called sedimentation analysis, which means that, see, whenever you want to analyze the soil can be analyzed by using the complete analysis of the soil can be done by using sieve analysis plus sedimentation analysis. The sieve analysis is basically taken for coarse grained soil, right? So if it is the soil has been completely analyzed, it has to go through 2 processes. One is the sieve analysis and the sedimentation analysis. For the sieve analysis, we know how the sieve analysis and sedimentation analysis has been carried out. So I'm not going to explain about the theory, but here you understand sometimes what they will do in particle size distribution curve. They are going to ask some of the name of the particular soil which has been formed through particle size distribution curve. Example, you see, if any soil which forms as a S curve, which indicates a well graded, if it is as I'm always saying about the term, the name which indicates a particular property of a soil. Here you see the gap graded. What is gap graded? Which means that the particles which has been missed from here to here. Simple, right? The same way, we know that the one more question they basically expect here is the particle size diameter, right? Sorry. So that is the effect. It is basically 3 different effective particle size diameters are there. One is D10, D30, and D60. What is D10? D10, which indicates that the 10% of the soil is finer. D indicates the diameter. And same way, D30 is also indicates that 30% is finer. In in the entire soil mass. The same way here, we are going to take these effective diameters to identify the soil. How we can identify the soil? Either by taking the CU and CC value. CU and CC value has been defined by using this effective size diameter. Okay, that I will be saying later. So in GATE exam, they are basically concentrate on two different types of soil classification system. One is called the BA soil classification, another one is unified soil classification system. I will go detail regarding this here. So what is Indian soil classification system is? Indian soil classification system is almost similar to our US soil classification system. The only difference we play, what is the difference? We'll see that. See, always you want to remember these things. What is that? One is the boulder. If you have the boulder which is have a size that is greater than 300 mm, right? So remember, there is a two important key parameters which is in the particle size. One is 0.075 mm, the important CU, as well as 4.75 mm. All the classification system has been taken place by considering the two important particle size. One is 4.75 and 0.075. The example here, you see the classification has been done by taking the 4.75 mm as a reference. If any soil which is passes, here is the left side, that is, if it is passes, if it is moving towards this direction, which says that it will be a finer particle, and if it is moving towards the right, what it is called, the particles which is higher, right? So according to IS classification system, if any soil which is less than 4.75 mm will be passes or will be considered the smaller material, that is sand. And if it is retained on 4.75 mm will be called as gravel, right here. So here you see the finest material you have to remember is the clay. Clay is a very finest material, and as the increase in the size of the particle, we can see that from clay to silt, then the sand has been classified into three different categories, that is fine, medium, and coarse. Again, gravel has been classified into fine and coarse. And the last one, the biggest material is the boulders. The biggest material is the boulders, and the smallest is the clay, right? So next one, I will be talking to you about the unified soil classification system. It is also one of the important soil classification system, because as you know that the other classification system have not considered the complete analysis of the soil. What do we call it as a complete analysis of the soil, which is basically called as analyzing both the sieve analysis as well as the plasticity index, right? So that is considering both the coarser part of the particle as well as finer part of the particle, which has been taken care in unified soil classification system. There is always a one question will be asked based on this particular unified soil classification system. In this, to mention the types of soil, the symbols have been used like this. The gravel will be used by indicated by G, sand is S, clay is C, silt is M, organic is O, and peat is PT, small pt. So based on what is the amount of the soil which is available, what is the amount of the gradation of the soil which is available, right? So which has been classified into well graded, poorly graded, low plasticity, and high plasticity. How to classify it, we'll see that. You see here, this is the flow chart. If you remember, you can easily get a 1 marks in GATE examination. That is, as I mentioned, the soil which according to unified soil, again I'm remembering, according to unified soil classification system, where the soil has been classified into coarse grain, fine grain, and highly organic soil. The soil has been classified into three categories, that is coarse, fine, and highly organic soil. Here, the coarse grained and fine grained soil have been classified by using the 75 micron sieve. What is that 75 micron sieve? That is here. 0.075 mm sieve has been used to classify the coarse grained and fine grained soil and the organic soil. If any soil which is retained, on 75 micron ISU will be considered as coarse grained soil. If any soil which is passes the 75 micron soil, which is called fine grained soil. Then later, you see, again, I'm saying in unified soil classification system, 75 micron is initially used to classify the soil. One is coarse and fine. Then later, the coarse has been classified into two further category by using 4.75 mm sieve. The 4.75 mm sieve, that's why I'm telling these two are the important sieve sizes. In 4.75 mm, if 50% is retained on 4.75, will be called as gravel. If it is passes, the 50% is passes, is called as the sand. Again, the gravel has been classified again by writing some symbol. What is that symbol? Example, as I told you people in the previous slide, we have mentioned G, which indicates the gravel, W indicates the well graded. How to classify it's a well graded or poorly graded? That we have been discussed in particle size diameter, where we have taken CU and CC value. So how to do that? We'll see next slide, right? So here you see GW. Now I have classified the entire soil into fine grain and coarse grain by considering the 75 micron. In 75 micron, if it is retained on more than 50% is retained on 75, it's coarse grain. If it is passes, it's called fine grain. Next, when the coarse grain has been classified into gravel and sand by considering 50% in 4.75 mm retained and passing. If it is retained on 4.75 mm, will be called as a gravel. If it is passes, it's called as a sand. Right? The same way, the gravel is again represented by using the symbols, that is G. If it is well graded, that is CU is greater than 4 and CC value if it is 1 to 3, which is called as well graded. If it is well graded, here as we know that the gravel and sands are the coarse grained particles, it has been classifying only through the particle size. We are not considering any water content. We are not considering any plasticity. We are not considering any consistency. Right? So here the GP, which indicates G indicates the gravel, W indicates the well graded, P indicates the poorly graded, it's a gravel. Right? The same way for silt and clay. So you can ask me what is this? The two symbols with the dual symbol which has been present while sieving the soil, that is through 4.75 mm. If it is retained through 4.75 mm, but if in a total mass of the soil, if more than 12% of the fines which are passes through 75 micron, then we have to indicate, right? Example, in a soil sample, the entire soil sample has more than 50% of the particles which is greater than 4.75 mm, but there is some amount of the soil which has less than 75 micron. It is of the percentage in between 5 to 12%. Always the dual symbol will come when it is from 5 to 12. You see here, if it is 5 to 12, so two numbers will come. So that you should remember. What is GW indicates? GW indicates as it's a well graded soil. What is GM indicates? It indicates that the well graded silt. That is M indicates the silt. Silty gravel. GM means silty gravel. What is GC? GC means clayey gravel. So how to indicate that? Example, DW, GW and GC indicates well graded gravel which has more than 50% of the soil which has been retained at 4.75 mm. Along with that, it is also having a clay fraction between 5 to 12%. Okay, the same way we can apply through sand. Same way we can go for fine grained soil. In fine grained soil, which has been classified based on the plasticity characteristics of the soil. Okay, that is by considering the consistency of the soil, low liquid limit, high liquid limit. Okay, so what is low liquid limit? Here you see what is ML. L indicates the low, L indicates the low, and H indicates the high. What is O? O is organic soil. What is C? Clay. What is M? M indicates silt. Right? So here the fine grained soil, we are considering the consistency. For coarse grained soil, we are considering only about the particle size. Remember that. Okay. So here you can see that is CU is greater than or equal to 4. It's a well graded. The group symbols are important. Always you will get a one question from this particular topic. Okay. So remember that. So GW indicates a well-graded gravel, well-graded or poorly graded gravel, like that. Okay. Next, move on. Next, as we move on, what is this plasticity chart? Unified Soil Classification System is also provided a plasticity chart for identifying the fine-grained soil. What they have done, they have taken and they have analyzed the different types of soils, and it is very easy to remember the plasticity chart for Indian soil classification system as well as for the unified soil classification system. Only difference here is that the entire plasticity chart will be divided into two parts at exactly at the center. Right? If it is less than 50%, it is called low. That is, the consistency is low. If it is greater than 50%, the consistency is very high. It is applicable in unified soil classification system. But when it comes to Indian soil classification, you have to draw another line. We have to draw another line here at 35%, which indicates that the soil, the fine grain soil, will be classified into three different categories. One is poorly graded, and another one is intermediate, and another one is high graded. Right? So that is highly plastic, that is intermediate plastic, and low plastic. Right? So that is where we can. Here you see everywhere we are going to indicate. Example, this is called an A line. That is Atterberg line. Sometimes the question will be asked based on the Atterberg line. What is the Atterberg line equation? That is 0.73 liquid limit minus 20. Okay, what is the unified soil classification U line? What is the U line equation? That is 0.9 into liquid limit minus 8. So that you can take. Here you see always the dual symbol of any soil will be represented here. Okay, which will be having a plasticity index from 4 to 7. From plasticity index from 4 to 7 will be indicated here. Okay, so next we'll move on. That is, next is consistency limits. Consistency limits plays an important role in identifying the fine grained soil. Why consistency limits are important? Because the consistency limits always varies with respect to change in water content. The water content is the main parameter to identify the fine grained soil, but when it comes to the coarse grained soil, particle size plays an important role, right? So here I'm talking about the consistency limits, are also called as Atterberg limits. We know that these limits will be based on water content. There will be there are 4 different states of the soil. Either it might be liquid state, plastic state, semi-solid, or solid state, right? So whenever the soil passes from one state to another state, the boundary line is always indicates the water content. That particular limit is called as the consistency limits, right? So if the soil is moved from liquid state to plastic state, from plastic to semi-solid, semi-solid to solid, if it is moved from liquid to plastic, which is called as liquid limit, it is the maximum water content where the soil is at the liquid state. Once this water content has been passed, it cannot be stayed at the particular same state. It will move on, right? So you can see here, as the increase in the water content, you can observe, or you can see here the line. Let me show it here. You see here, as we move towards the downward direction, we can observe that there is a decrease in volume. Here we see in the y-axis, as we move from the upper side to the downward, there is a decrease in volume up to certain limit. That particular limit is called the shrinkage limit, where the soil is completely saturated and you cannot expect any change in the volume of the soil when the soil which reaches the particular shrinkage limit. So here you remember always the consistency limits plays an important role for the fine grained soil, where liquid limit, plastic limit, and as well as shrinkage limit. In shrinkage limit there is no volume change, but also remember one thing: whenever the soil is in liquid state, always it possesses zero shear strength. The shear strength of the soil will be null, zero. It cannot hold any amount of the resistance. Okay, so the next part, that is the next topic, I will be talking about the clay minerals. What exactly clay minerals? We know that the soil has been formed. Some of the soil which has been formed through using the clay minerals, right? So the basic structural element which always present in the clay minerals are the 2 units, which is called tetrahedral unit and the octahedral unit, where the tetrahedral, as you see, the structural unit of the particular clay mineral, which always forms in terms of by combining 4 tetrahedral shape. You can see here, right? So the tetrahedral shape has been formed by one silicon atom at the center will be attracting the 4 oxygen atom. Okay, one silicon atom, you can see here, one silicon atom will be there here. It will be surrounded by 4 oxygen atom. Remember always, in tetrahedron, silicon 4 plus, Si 4 plus will be available. The total net negative charge will be 4, and it is also called silica sheet cannot be exist, or a silica atom which cannot be exist individually. So what they will do, they will form a group and make a sheet type of a structure which is called a silica sheet. It is also represented by, I will show here. Okay, it cannot stay individual. So what they will do, this one complete 4 ions you can see here from the top view. So all have been joined together. They are interlinked and they are going to form a sheet. That particular sheet is called a tetrahedron sheet or silica sheet, which is basically represented by the symbol like this. Okay, the same way it is there for octahedral head or octahedral unit. Claim the basic structural elements for the clay is the two. One is called tetrahedral and octahedral unit. Here you remember always the silica sheet has been formed by tetrahedral unit and the gibbsite sheet has been formed by the octahedral unit. In tetrahedral unit there will be a silicon atom, but in octahedral unit there will be an aluminum atom. Okay, so this is how it will be formed. What are the basic important clay minerals? Clay minerals, right? So now we talked about these clay minerals have been formed through the sum of the structures, the basic structural units. Now, what is these four clay minerals? The clay minerals are kaolinite mineral, halloysite mineral, and montmorillonite mineral, as well as illite mineral. You see here, this is, and always, as I mentioned about one question from the clay minerals part. Clay minerals part, there will be a one question. Always we can expect the combinations, we can expect the strategy there, right? So we can easily remember these four different types of clay minerals. That is, the kaolinite is basically a kaolinite group. It is always formed by using the alumina sheet and silica sheet one above the other. We saw that the silica sheet will be formed like this, and the gibbsite sheet, the alumina sheet, will be formed like this. Remember, the kaolinite has a 7 angstrom thickness and it is stronger. It is strongest clay mineral, right? So it is having a specific area of 15 meters square per gram. China clay is an indication of kaolinite group. Sometimes I will be asked, what is China clay? Which group it will be indicated? I have asked, I think, twice, right? So which is the mineral which represents the China clay, which is called as kaolinite mineral. And remember, the kaolinite group of the mineral has been taken place by the combination of the hydrogen bond. Okay, next, what is halloysite? Halloysite is basically, it is same as kaolinite group, but only thing is there we can expect the sheet type of the minerals, but here it will be tubular form. It will be a tubular. You can see the electron microscope of the halloysite. Remember, tubular shape is for halloysite. Sheet-like is for kaolinite. Sheet is for kaolinite, tubular is for the halloysite. Okay, and here comes the dangerous clay as well as the most important clay mineral, which is called as montmorillonite. Why it is dangerous or why it is important, why it is interesting? Because it is always sandwiched between the two different types of silica sheets. The thickness of the particular montmorillonite clay is very high. We know that the number of problems which is happening in the nature, especially in clay soils, it is only because of montmorillonite clay. What is its specialty? This is the specialty of it. We can expect the hollow space in between the silica sheets. So due to this, due to this hollow space, it is always sometimes even the water fills. When the water fill into this particular halloysite, it is going to expand. Whenever water evaporates, it is going to shrink. So the most shrinkage and swelling property we can expect, it's only from montmorillonite. The most shrinkage and swelling will be exhibited by montmorillonite clay. Remember, it is only because of the water which is present here. It is weakly bounded by water, van der Waals force. You can see here. It is weakly bounded by van der Waals force. Okay, so that is the main thing and important thing. Thickness of the montmorillonite is 10 angstrom. One time they have asked the thickness, one time they have asked which is the kaolinite group, one time they have asked about, so what is the specific surface area, right? We can go through it. Here you see, it has been formed like this. We can always expect the space here. The thickness is 10 angstrom and it has been, each montmorillonite clay has been formed by a van der Waals force. Okay, remember, that's why it is danger. But what sometimes this particular montmorillonite clay is going to have an isomorphous substitutions by exchanging of the electron through the iron magnesium. Remember, isomorphous substitutions is possible in the clay minerals. Okay, and it is also having the highest amount of specific surface area, which is 800 meters square per gram. What is specific surface area? as the term itself indicating that area of a surface which can be filled by 1 gram of particular clay mineral, which is called as specific surface area. Okay. So next one is illite group. What is the beauty of the illite group is that here you see it is same as the Montmorillonite clay, but it is not going to exhibit the maximum amount of swelling and shrinkage as compared to Montmorillonite, because there is a potassium ions which is present in between the two bonds. Due to that potassium ions, this illite material will not going to exhibit the maximum amount of shrinkage and swelling. And remember, it is also having same thickness of 10 angstrom. And remember, Montmorillonite is a Montmorillonite group and illite is a illite group. But only kyanite as well as halloysite comes under kyanite group. Okay. So, and also you see here the specific surface area is 475 meter square per gram. So the maximum specific surface area is also for Montmorillonite. The maximum thickness is for Montmorillonite, as well as the maximum swelling and shrinkage can be expected only from Montmorillonite. And it also has larger negative charge in illite mineral. That's why it is a little bit stable. Okay. So now here comes the two important parts, as I mentioned, which is of what one thing I talked about, that is the property of the soil, and second one I talked about the clay structure, and third one I talked about the clay minerals. Correct. So we have to remember the important key elements here is that before I'm going to summarize these three topics. What are the three topics I was talked about? One is the property of a soil. Second one is the clay minerals and the structure or the particle size distribution of the soil, right? So in basic properties of the soil, always remember the formation of the soil has been taken place through the cyclic process by taking the weathering. Weathering can be the different kinds of weathering they can ask, but in that particular formation of the soil, remember the two important key points in formation of soil, how the process will take place. That is the one thing. And the second thing, what are the agent? What are the agents? As I'm talking about the transporting agent for the soils, right? That agent matches the particular formation of the soil. You always search for the particular hint in the particular word. You can easily get it. Okay. So that is the one thing you have to remember in formation of the soil, right? So the second one I have talked about the basic properties of the soil. In basic properties of the soils, we have to remember what is void ratio, porosity, everything. Let me summarize as quick as I can. Okay. So here what I have done, we have come up with the formation of soil. In formation of soil, I told you to remember this particular slide where the agency will come up with the particular type of soil. So remember it. So next one I told you regarding the constitute of the soil. Here you have to remember this particular diagram where the volume will be represented on the left side of the phase diagram and the weight will be represented on the particular right side of the diagram, which has been indicated by using the respective parameters. If it is a weight of the air, if it is a water, weight of water, if it is a weight of solids, and if it is a volume, that is, if it is a volume, that is, we can go with volume of air, volume of water, volume of solids, right? So the same way, when it comes to a particle size distributions, we have to remember in particle size distributions, you have to remember about effective size diameter, CO and CC. How to classify the soil based on CO and CC, and also we have to remember about how to classify the soil based on its particle size distribution. And the important one, we know that it is a Indian soil classification system where the finite particle in an Indian soil classification system is a clay, and the largest particle is a boulder, right? And as I told you people regarding, we should not forget the 75 micron as well as 4.75 mm, because if any soil which passes the 75 micron, which basically we call it as a fine grained soil, and 4.75 mm, which basically help us to classify the coarse grained soil into sand and gravel, right? So then we have talked about unified soil classification system where every terminology and every symbols which indicates, right? So G indicates gravel, S indicates sand, silt indicates M, clay indicates C, organic indicates O, peat indicates PT, as well as based on the gradation will be classified into well graded or poorly graded. Based on consistency or plasticity, we can go for H and L. Then we talked about unified soil classification system, where we have to remember coarse grain classification is taken place through grain size, fine grained which taken place through consistency. The organic soils has the very low specific gravity, because when we talked about the specific gravity, it is basically about any substance with respect to a standard substance. But what will happen if any substance which has a specific gravity less than 1, which basically floats, right? So that is what will happen whenever the specific gravity is less than 1. Right? Next, we talked about the plasticity chart. Here we have to remember plasticity chart can be represented by using the two different systems. One is unified soil classification system and another one is Indian soil classification system. But first has been derived by unified soil classification system, which has a U line, and it has been drawn by using 0.9 LL in minus 8. What is LL indicates the liquid limit. Later, in unified soil classification, which has divided exactly at the middle, right? Middle into highly organic and lower organic. But when it comes to the another one, right, that is Indian soil classification, has again divided by at 35%, right? So now next we talked about the clay minerals. In clay minerals, we have to remember that the kaolite is the strongest, and China clay is also called as a kaolite, and 7 angstrom is its thickness, and halloysite is basically a tubular clay mineral. Montmorillonite is basically of exhibit maximum shrinkage and swelling with a maximum surface area of 800 meters square per meter. Along with that, it has a thickness of 10 angstrom that has to be reminded. And in illite group, it is basically of a non-exchangeable potassium ion, plays an important role. Okay, so now let me go for the last 5 minutes of the session, where what I have done. So in the initial stage, in the initial analysis, I have shown you people up to 2018. Now here I have taken 3 to 4 questions from the particular GATE questions. So here is the first questions, which says that in GATE 2018 first session question, which says that the notation of SC as per Indian standard soil classification system refers to what is C. C indicates what is C? C indicates the clay. What is S indicates? S indicates the sand. So sandy clay. We can go for here. So wherever we can search, you can search here. Clay sand. Okay. So that is the one question which has been GATE 2018. Second one, the clay mineral whose structural units are held together by a potassium bond. We know that the potassium ions has been available in a illite group. That's why I told you, remember. So in potassium bond, we can go for illite. So the answer is illite. So the third one, a core cutter of 130 mm height has inner and outer diameters of 100 mm and 106 mm respectively. The area ratio of the core cutter, here why I put this question, because it has been related to the density of the soil, where we know that the relative density it also comes under in situ density of the particle. So we can also expect the same question from subsoil exploration, where you will talk about the samplers. So I can take this question there. So the another questions we have is shrinkage limit test. The shrinkage limit test, the volume and mass of the dry soil part are found to be 50 centimeter cube and 88 gram respectively. The specific gravity of the soil solids is 2.71 and the density of the water is 1 gram per cc. The shrinkage limit in percentage up to 2 decimal places. That is the question they ask. Here is the shrinkage limit. We know that this question has been taken from the consistency limits of the soil, where as I told you people, regarding there is no change in the volume of the soil, where we can expect the shrinkage limit, the limit of the particular water content, or the limit where the volume that doesn't change. So apply the equation of 1 by P by 1 by R, which we will get through shrinkage limit test. That is by dry part that you have. Here I'm not going to explain that particular iteration. So you can go through that and you can easily get the answer will be around 19.50 to 19.20. Okay. So I have put a small question, one question for put myself as well as for you people. So here is the questions that basically sometimes they will make a use of the application problem. So here is one question is there for you people. So how many cubic meter of the earth fill can be constructed at a void ratio of 0.67 from 19,000 meter cube of borrow material that it has a void ratio of 1.1? So I will give a hint, you can solve and go through it. Okay. So what is the question? Question is very simple. It has been taken from the properties of the soil, but it is little bit indirect. What they're asking that how many cubic meter of the earth fill can be constructed? How much earth fill you can construct by using a void ratio of 0.67 from 19,000 meter cube of borrow material, that it has a void ratio of 1.1. That is, you have to construct a road. Assume you have to construct a road over there. The void ratio should be 1.1. It should be borrow material that it has a void ratio of 1. Okay, so you have to construct a road over there. The void ratio should be 0.67, but you are taking a material from somewhere. That material. Oh, okay, so fine. So here, what we have done with the how many cubic meter of the earth fill can be constructed at a void ratio of 0.67 from the 19,000 meter cube of borrow material. That is, it's at void ratio of 1.1. Here, you go that the earth fill we have to construct by using 0.67. But the material we are bringing from the site, which is of 19,000 meter cube of the volume, where the void ratio is 1.1. So now what you have to do, you have to calculate what is the volume of the solids or what is the volume of voids which is available in the soil. So get back to me by calculating what is the amount of the road we can construct by using a soil which is taken from a field of 19,000 meter cube with a void ratio of 1.1. You are going to construct a road which is having a void ratio of 0.67. Okay, so this is what the things I have been planned for you people to explain about the three different topics. Now, as we know that our MC is the writing the question, so she was telling me there is only another 5 minutes, so let me answer the question here. So okay, which soil has low permeability? Okay, when it comes to a permeability of the soil, what is permeability? The term itself indicating permeable. So which means that if any material which allows the water to pass through it, that particular material is called as permeable, right? If it is a soil, then it's called permeable soil. Which soil has low permeability? Example, let me give the example of the gravel, sand, silt, and clay. We know that even though the silt or a clay which has very minute particle, we might have think it will be having more permeability. No, but the gravel which has the solid mass of, here I will show you. So you can see here. So we know, let me take this one. Yes, yeah, here you see this skeleton, I will take it as a gravel. In the gravel, you can expect, you see here, the voids are more. When the voids are more, what will happen? It will allow the water to pass through it very more amount of water can be passed through it. But take this solid part as a silt. Okay, here, when the water is allowed, what will happen? It will take a lot of time to penetrate into it because the voids are not there. There is no space. There is no space in between the solids as compared to the gravel. So I will say which of the soil has low permeability. The low permeability can be expected from the fine grained soil. If you ask me particularly which is the fine grained soil, I will say it's a clay minerals. If any soil which has the dispersed structure which will possess a low permeable in fine grained soil. Good. Can you explain particle size of CU and CC again? Okay, so let me take it through this one. So what is CU and CC? Fine particle size distribution, CU and CC is basically soluble. CU, uniformity coefficient. CC, which means that the coefficient of curvature. These two classification has been done by considering the effective particle size diameter. What is effective particle size diameter? It's basically three different types of effective size diameters are there. One is D10, another one is D30, and another one is D60. What is D10? D10 indicates that 10% diameter of the soil is fine. What is D30 indicates? 30% diameter of the particles are fine. What is D60 indicates? 60% of the diameter of the particles are fine. Okay. based on using this particular effective size diameter, we can classify the soil by defining CU and CC. CU is basically defined by considering, that is, DCU equal to D60 by D10. So as I mentioned, D10, D30, D60. So CU equal to D60 by D10. What is the ratio you will get? That is CU. What is CC? Which is equal to D30 whole square by D10 into D60. So which can be classified, okay, here you see, if the CU value is greater than or equal to 4, and if CC equal to less than or equal to 1 to 3, it is called as the well graded gravel. And if it is C is less than 4, and if CC is greater than or in between 1 to 3, we can call it as, which is a clean gravel which is less than 5%. So we can classify the coarse grain soil and fine grain soil according to the amount of CU and CC. Here you see at the bottom we have represented for different classification in a plasticity chart. I hope you have cleared that particular answer. Is it sandy clay or clay sand? Is it a clay? For the question that we have given here, I think for this one you are asking, right? So here you see, is it a sandy clay or a clayey sand? That is the question they are asking. Why they are asking it is a sandy clay? Because the S has been represented at first and clay has been represented at the second, right? But always represented in the classification system, the second letter which indicates when two different types of the same soil which has been available. If we are not classifying based on gradation, we are considering two different soils. One is clay, another one is sand. Okay, so in that particular system, we will represent the second as the first term, that is C, which indicates the clay, and S indicates the sand. Okay, so the next one. Okay, good. There are two students, they have solved the last question and put up the answer in the chat box. Good to see that. The last question. Okay, here. For the last questions, the Abhishek as well as Hitaishi has been put up, and they're asking me whether the answer is correct or not. They're saying me that the answer is 15,109.5 meter cube. Okay, for that I have given explanation here. See here. So this is the solution for the question. So I was expected the question, so it was good. I thought of taking the solution in the next session, so it's fine, no problem. So here, what is the question? We know that we have to construct this particular road. By using a void ratio of 0.67. So to construct this road, we have brought the soil from the field, which is of amount 19,000 meter cube. The volume is 19,000 meter cube with a void ratio of 1.1. I want to construct a road which is having a void ratio of 0.67. Fine. Okay. So what I have done, the known values are volume is known, the void ratio has been known. Right? I have defined the void ratio. That is void ratio. We know void ratio. Again, I'm saying we are defining only ratio of a voids. Volume of voids with respect to volume of a voids with respect to volume of solids. What is volume of voids? Sir, there is no volume of voids here. There is only volume of the solids we can expect. Or we know the total volume. So how to take it? We know that the total volume will be equal to volume of voids into volume of solids. The total volume equal to volume of voids plus volume of solids. So what I have done, I have related both the equations, so I can only get two variables. Right? So here there are three variables. I will going to get only two variables out of which I can relate this void ratio. So what I will do, I will replace this volume of voids in terms of void ratio. That is void ratio equal to VV by VS. So VV equal to E into VS. When it is equal, let me show it. That is here. I have related it. So VV I will get E into VS. What is E into VS? E into VS, I will be substituting VV. So the total volume equal to VS into 1 plus E. So the total volume I know, which is 19,000 meter cube, as well as the volume of the solids. I don't know how much is the volume of solids. So only one I know, but I know what is the void ratio. The void ratio is 1.1. Get the volume of the VS. Once you calculate the volume of solids, it will be fixed. because you cannot change the volume of the solids. We know that it's a permanent. When we're talking about a soil, or the internal composition of the soil is basically of even the voids. Inside the voids, there may be a number of composition changes, but the solids doesn't change. So the volume of the solids will be constant, right? So the volume of the solids, once you determine the volume of the solids, next what you have to do, you have to calculate how many volume of the soil can be constructed. So again, use the same equation, V equal to Vs into 1 plus E. So here what I am going to do, I am going to take the E value rather than 1.1, I will be going to take E equal to 0.67. Anyway, we know that the volume of the solids are same. How much is the volume of the solids? That we will get through this equation by using these two parameters, right? So now you can easily able to get what is the total volume. The total volume of the earth that can be constructed using that particular thing. Okay. Now anyway, so with this, shall I? Yes. Okay. So with that, I am going to hand over my next session to my one of the colleague. So before that, exactly, I'm going to finish at my particular time. And before that, thank you for listening the first 3 topics in geotechnical engineering. That is, in a second session, it will be on December 1st. I will be taking you through the problems, because we know that this all the theory part we have been studied, because it is the basics which is required for a particular subject, right? So this is the 3 topics we have been covered today. So in the next session, the first session is over. The next session will be talking about compaction, effective stress and permeability. This is the second session. And okay, that will be taken in the next question. Okay, there's one more question is that you can, how we can take, what is the percentage of the marks in soil mechanics and foundation engineering? That is the question I asked myself. So here, when I done the analysis, we can expect a marks of around 6 marks in a solid mechanics, and you can expect more than 8 to 9 marks from the foundation engineering. Good. Okay. So with that, I'm going to conclude this session, and thank you everyone for listening. And here is my final slide. So here I'm going to stop the session by saying that whatever happened is happened, but the future is uncertain. Save our earth. Save our earth. We are doing a lot of damage to the earth. It is important. Save us. Thank you. Now I will hand over my session to MC.
Thank you, Chethan, sir. You have explained very precisely the concepts which has more weightage in GATE. I hope all the participants, the students have benefited from box. You can find all the descriptions, the schedule of the itinerary of all the sessions of all the 15 days, and also the GATE syllabus link. Everything will be put up in the description box of each session. The participants can access that also. And we'll have a short break of 15 minutes now. The dear participants, please join back the live stream at 3:45 p.m. exactly for the second session using the same link. So see you all at 3:45 p.m. again. Thank you, everyone.